and listed out in symbols is going to look like this. But this one has the caret symbol, so let's rewrite it like we normally would. It's going to have cosine, and then it's going to look like it's being raised to a -1 power. But you simply say this as the inverse of cosine. Inverse cosine used to be called arc cosine, so you might still see that type of naming going on. But all of these are all related to our main topic today, which is inverse cosine. Since we're talking about inverses, let's go back and review about finding the inverse of an equation. When you find the inverse of an equation, you switch x and y. Because x and y switch around, so do the domain and range. Keep that in mind when we do inverse of cosine here in just a bit. On a graph, when you're trying to find the inverse, you reflect the original graph over the line y equals x. If you draw a quick graph here, and you graph the line y equals x, the line y equals x is a diagonal line through quadrants 1 and 3. So if you take your graph and reflect it over this line, you'll get the inverse graph. The question today that we're going to be looking at, the word problem, involves ladder safety. So there was a discussion today in class about how to quickly and easily find out if the angle that you're making with the ladder against the wall is a proper angle. You simply stand on the bottom rung, hold your arms out in front of you parallel to the ground. If you can easily reach the ladder, then you know that you have a safe angle to climb it. If your arms don't reach, then you know that it's an unsafe angle. Or if the ladder is too close to you and your arms are bent, then that's also an unsafe angle. That's a technique that we use as firefighters on the fire ground when we're putting a ladder against a wall. We don't really have the ability to measure the angle with a protractor, so here it is as a practical example. The links here on YouTube are just 2 quick links to direct students to situations where firefighters did not foot the ladder properly, and you can see that the result is that people slip and fall. So those are just there for your viewing pleasure. We're going to get right into the example here. A ladder is deemed to be unsafe to climb if the angle it makes with the ground is less than 75 degrees. So we're going to calculate this question and figure out what the angle actually is, and then determine from here if it's safe or not. If you place the 16-foot ladder against a wall, so that its base is 5 feet away, is the ladder safe to climb? So we're looking at the angle here that the ladder makes with the ground. Obviously the wall has to be perpendicular to the ground. The ladder here is the 16. Looking at what we have, we know that related to the angle that we're looking at, we've got the adjacent side and the hypotenuse side. Because of that, we've got A and H, so this should be a cosine problem. When you set up a cosine problem, if the angle is what's missing, leave room in front of your fraction so that when we solve this, we can input an inverse cosine. The only way to get cosine to go away is to use an inverse. So we just put inverse cosine on both sides of the problem. When you type in inverse cosine, you'll have to use the trig button on your calculator. If you have a gray TI Inspire calculator, you just do second and then cosine, and you'll see this little -1 show up. And then you type in 5/16, and when you round that off, you should get about 72 degrees for theta. And that's assuming that we're rounding to the whole number. Since we got a 72-degree angle, which is indeed less than 75 degrees, is the ladder safe to climb? We're going to say no, it's unsafe. And if we needed further explanation, we'd say because the angle that it makes with the ground is less than 75, which is deemed unsafe. Let's talk further about the inverse cosine restrictions. When you're working with inverse cosine, the only options available to you are between 0 and pi. Those are listed in radians. If we rewrite this in degrees, it would be from 0 to 180. So if we think about that in terms of the unit circle, we're only talking about quadrants 1 and 2 being available to us. Here it is on the graph. Here's a graph of regular cosine. Remember that the domain of regular cosine is all reals for the domain and -1 to 1 for the range. If we look at that graph and try to come up with its inverse, we would be reflecting this line over the blue original graph. We'd be reflecting it over the line y equals x. If we do that, we're going to get a nice squiggly line going vertically. That vertical line will not pass the vertical line test, so we're going to restrict the graph in such a way that we're only going to look at it between 0 and pi. So we basically cut off the graph here and here, and we imagine that the rest of those pieces do not exist. Now we're going to take that and do the inverse of just this portion of the graph. Remember that when you do an inverse, the domain and the range switch as well. So here's what the inverse graph is going to look like. Here's the original restricted cosine graph. Now we reflect it over this line y equals x, and we get the new red graph. There is an error in your textbook. The domain is listed as -1 to -1. Make sure that you have it listed as -1 to 1, and then the range becomes from 0 to pi, or from 0 to 180. When you do a restriction, there are 3 things to keep in mind. These are directly from your textbook. The domain needs to include values between 0 and 90, because those are the measures of acute angles of a right triangle. And whenever we're working with sine, cosine, and tangent, we always want to be working with right triangles. Our domain here goes from 0 to, the range goes from 0 to pi, so we're well within covering number 1. On the restricted domain, the function should take on all the values of the range, that is all real numbers between -1 and 1, and we do have that. The function should be continuous, meaning you can draw it without having to lift your pencil. There are no asymptotes that we have to jump over, so we're doing fine there. So we've satisfied all 3 conditions here. So now let's look at what students are going to have to do related to this restricted domain idea. On tests and quizzes, you would be using a baby calculator only to answer questions like these. When you did the unit circle quiz back in chapter 4, I asked you questions like, what's the cosine of 30 degrees? Your response was an exact value. When you reverse this process and do the inverse will ask you for will give you an exact value, and your job is to give the angle measure that it came from. So it's the same as the unit circle question, just kind of in reverse. So if we're doing the inverse cosine of square root of 3 over 2, we know that the answer there is going to be 30 degrees. Keep in mind that when you're working with inverse cosine, you might be working with either degrees or radians. So we're going to do both as we do all 4 of these questions. 30 degrees in radians is pi over 6. If you didn't know that, hopefully you could convert 30 degrees to radians by multiplying by pi over 180. That's a review from chapter 4 as well. Next up is arc cosine. Remember that arc cosine is the same as inverse cosine. -0.5 is the same as -1/2. So again, think of your unit circle. Where is the cosine equal to a half? Remember that the cosine is the x value. So we want to imagine on the unit circle where the x value ends up being a half, and that happens up here at 120. And the cosine, or the x value there, is negative, so 120 is our answer. In radians, we'd say 2 pi over 3. On a question like the third one here, a lot of times kids will just take the easy way out and say that the cosine and its inverse will cancel each other out. While that is true, you want to be careful about the restricted domain. When you're working with inverse cosine, remember you can only give answers between 0 and 180. So instead of just canceling out the cosine and its inverse here, I'd recommend going through the order of operations. The order of operations indicates that we should figure out the inverse cosine of square root of 3 over 2, which we knew from our first question to be 30. So I'm really going to calculate the cosine of what I got for my answer on this interior portion, which I know was 30 degrees. Now when I do the cosine of 30, I get square root of 3 over 2 as my final answer. So on this question, I guess it is true that the cosine and its inverse do indeed cancel each other out. That is because square root of 3 over 2 is in quadrant 1. On the next question, however, that will not work. If you try to cancel out cosine inverse and cosine and say that it's equal to 210, you will get it wrong. 210 is located in quadrant 3. That is outside the restricted domain, so we can't simply cancel these two out. So let's figure out the cosine of 210, and then let's do the inverse cosine of whatever we get. Cosine 210 is going to be negative root 3 over 2, and we know that the inverse cosine of that is going to be similar to what we had back here for 30. Negative square root of 3 over 2 is going to be at positive 150. We know it's going to be in quadrant 2 because it's a negative value. Root 3 over 2 is at this spot right here, which is 150. In radians, we would say 5 pi over 6.